Alright, I got a Danfoss ADAP-102 ADAP-KOOL drive. Just want to check to see if the sensors are reading right, because it hasn't been really acting the way it should, I don't feel. So, and then I'll check the parameters. But I'd like to display the outdoor ambient temperature right there. I believe this figure is, we can find out. Hold on. The quick menu, function, general, display, 1-1, okay. Analog input 54. Hold on. Take the cover off. Liquid pressure input signal. So I guess that's displaying up here the voltage what's coming to that input, but I want to see the outdoor temperature, so we gotta find, I kind of forget. No, it's external reference. That'll show us outdoor temperature. Now, I don't know the voltage for what will display, because it'll automatically convert the pressure to temperature in the VFD, and I believe that's what the drop leg pressure conversion is. And that's the voltage input on 54. But we want to read external reference. We're getting 52.6. My thing's saying right around 60. So it's a little off. I can change that. There's the drop leg pressure transducer. Oh, fuck. Well, that sticker's gone. Maybe we can look at the other one here. Now, I'll get a Danfoss transducer if I need one, not these ACI. So, I don't know if you can see it. Zero to 400, 1 to 5. So range 0 to 400 psi. Signal voltage will be 1 to 5. That's an ACI. So I would assume it's the same one. All right. Well, I got that reading. Let me turn this back on. So back. I want to go to my personal menu, I believe. So we do have 460 volt motors, 60 hertz, current 27.4. You just look at your motors. I already checked this. Well, no, not on this rack, on the other one. See what it'll be on the nameplate, but occasionally it might be different. But you want to check all your motors, make sure they're all the same horsepower, same full load amperage, same RPMs, and kilowatt. When you go to the kilowatts, it gets a little more, you almost have to do some algebra, but you likely won't have to get into that. So we got 850 RPM. Oh, all you do is add up all your motors, and that'll be your motor current figure right here, and you can change that if it's not right. 850 RPM, that's right. Warning speed 900, that's fine. Now terminal 54, that's the liquid input we had. Liquid input. That's reading the liquid drop leg down over there. So, and we have a liquid input 54 high reference, and we do have a 0 to 400. So that's right for that transducer. Not sure what that is. I'd have to read more. Minimum reference. So, you know, you could just get your pressure temperature chart. Real quick, give me a second, sorry. I don't know if you can see the other screen. So we want bubble because we're looking at the liquid after it's subcooled. So 77 degrees, we already have. Shit, I'm trying to do it looking through the damn. It's 167 PSI. And that's 407, you gotta make sure. So that's the low. That's the minimum reference. So you really shouldn't see the pressure too far under that. It should really kind of. And then the maximum reference. 289. So, I mean, these should already be set from whatever the engineers have decided to run it. But I have occasionally come across seeing them goofy, and even the RPMs being set way too high. So we do have to run the right refrigerant. Comparative values. Now these are another thing that I know in the past I've had to change comparative value 0. So you got to click on it to see the other comparative values. And then 1 was the only other one that I've had to check. And I have looked in the book, and this is what Danfoss will have for 407A with a 0 to 400 transducer. If you're using a different, if you switch the transducer to a 0 to 500 Danfoss ADAP-KOOL, I believe, you're gonna have to find out. These numbers will be different. Now I could find that information for you if you ever needed it or can't find it. So, actually, let's look right here. I have it in a. Let's see if I can pull it up, because I have a page here somewhere. Sorry, bear with me. I know this video is going to be long now. I didn't want it to be. So, let me edit this. Done. So, alright. So, 407, 0 to 400, comparative value 0, 24. And that's actually 140 PSI. That's split cut-in. That controls the split cut-in, that's it. And for 30.5. So we have 24, which is what we're supposed to have for a 0 to 400 transducer. And on comparative value 1 for split cut out, we have 30.5. All right, that's good. That's good. But we're reading 80 degree Fahrenheit right now. Let's look at our pressure. 150. 150. So let's go here. 150 on bubble. 70.47. And we're reading 80. Now this hasn't been going in the split like it should. It's been kind of random. 53 degrees on the, so that's off by like 7 degrees. I got to get a transducer, and I'm going to reprogram it. I'm going to get a Danfoss transducer 0 to 500. So I'll have to reprogram the comparative values and the input signal. So this is coming from the ACI to 54 and 53 is in there, these two. This is 54, 53 ground. They have it wired over to here on terminal 13. Can't see it there, but you can probably see it here. Which is 24 volt DC. The Danfoss ones, I'll wire it to 50 because they're 9 to 30 volts. So I can wire it on 50 for the supply voltage to the transducer. And then just wire in, oh no, I'm sorry, yeah, 55 wires black to ground, and then the white will go to the input, 1 to 5 volt. And you just have to make sure it's set right, which we know 1 to 5 volts is set right. I just checked that. But we'll have to set the parameters for the transducer because I'm going to get, like I said, the Danfoss one. So, all right, that's a quick overview of the. And that's only like, it's only a few degrees off, but you know, I'm gonna get a sensor and a transducer and see if we can get this thing to go in the split properly and control the head pressure a little better.